Okay, so we're still in experiment number 8. I got to look up there, keep track of things. And we're going to actually look at the magnetic field as we go up and down the axis of the coil of wire. And so we got this set up from the last time. So right now there's 0.963 amps of current flowing through the coil of wire. And we've got this set up with a graph now, so if you go over here, you can see we've got position on the x-axis and we've got the magnetic field on the y-axis. Then we're going to collect the data over here in the data table, and normally you would take that data and export it over to Excel, and then you'd plot your graphs in Excel, because Pasco doesn't do a very nice job plotting graphs, and you generally have to make little changes to make the graph look as good as possible. All right, so we've got a graph of B field versus position, and this is how we measure the position. We're going to put a string around the neck of the sensor there. I got a slip knot on here, and I'm going to tighten the slip knot. So we got a good grip like that. And then it's going to hang over a rotary motion sensor. And we're going to put 50 grams on there, and that will keep enough friction so that when I move this thing, you can see it's moving the rotary motion sensor. All right? And I'm going to start right smack dab in the middle of the coil, and I'm going to travel down here about 12 centimeters, and then I'm going to come over to the other side and go 12 centimeters. So basically the extremes of what I can get to on this track here. And it looks nice if you get the data so it's equal on both sides. And if you really want to be, you can actually trim the data when you get it. But anyway, we're going to start right there, smack dab in the middle. I've already zeroed the sensor out using the old degausser. Remember, that's a degausser right there. Gets rid of the Earth's magnetic field so it doesn't interfere with your data. And on the screen right here, we have a common rate. So we're taking 50 measurements per second from the magnetic field sensor and the rotary motion sensor. So we get a data point for every single 1/50th of a second. We don't miss any data points. When I first started teaching the lab, I didn't know about that feature, and so we'd get one measurement and then we'd get like 10 measurements of the other sensor because it was set at a different sampling rate. But we want to have the same sampling rate when we do it. And Tom's going to go ahead and turn it on, push collect, and you let me know when you got it. Go? All right, here we go. And by the way, it doesn't matter how long it takes you to take the data, because we're not looking in time, we're only looking in distance. Okay, you can turn it off. And that's it. Look on the graph there. Is that spectacular or what? So you can see as you get further and further from the center of the loop, the magnetic field goes down. Let's see how many centimeters I went. That's good. I like to go 12 on both sides. That one I went really far. But anyway, you could trim it and make it look perfectly, symmetrical. But you can see I set the position of the zero. Look at that. Bam, right there. I was right smack dab in the middle of the coil. And that's what the B field looks like all along the axis as you change the position. So that's the second experiment. It can be linearized, believe it or not. You could linearize that data, and you're going to linearize that data. I will give you your own sample of the data. You can go back and look at the videos and see exactly how it was done. So when you write the procedures, you're going to want to look at this and put it into your own words on how it was set up. And if you ever have any questions, you just email me and I'd be glad to help you out. And I also have office hours as well. Okay? So that's it. Lab 8 is done.